Last, we talked about finding out time for meridian passage of sun, planets, and moon. Let's talk about stars. Uh, this is just a little bit uh, about time, which I'll be talking to you in detail once we get down to the topic of time. This is just for an idea of what a sidereal day is about. Rest, I'll be coming to it in detail later. We know that the Earth rotates and revolves and goes from west to east along its orbit, and the rotation is day and going round creates the seasons. Now, Earth, the direction of Earth's movement, we call a day when you have the same meridian coming back to the sun. So, apparent solar time, I'm using the word apparent solar time because I'm talking about this true sun here. So, when we have two successive transits of the same meridian from the sun, it's called apparent solar day. Now, Kepler said in his rules that the planets revolve round the sun in an ecliptic orbit, with sun situated at one of the foci of the ecliptic. When a planet, in this case we are talking about the Earth, is closest to the sun, we use the term perihelion. And when it is further away, we use the word aphelion. Of course, these are not the positions. This is just for understanding part of it here. So this is what the first law of Kepler speaks about, that they are moving, the planets are moving around in an ecliptic orbit with sun at one of the centers. The second law of Kepler states that the radius vector, that is the radius of joining the center of the Earth and center of the sun, sweeps equal areas in equal amount of time. So this is one area, this is nearly the same area as basically the distances apart. So here, so the Earth will be traveling from this point to this point, or from this point to this point in equal time. Now to complete one apparent day, which we said that the sun should be back onto its the meridian again, the Earth would have to go 360 degrees plus this angle theta at perihelion, and at aphelion it will have to cover up this angle 360 degrees plus this angle, which is a smaller angle than the angle here. So the apparent solar day would be larger here compared to this, because here the angle what the Earth has to rotate extra is greater than the angle what is here. So you have a longer day here and a smaller day when this Earth is at aphelion. Now if we were taking the time with this true sun here, then we would have to have a clock which is going to show different duration throughout the year. And that is where we have come up with mean sun. And two successive transit of mean sun over the same meridian, we talk about mean solar day, and we have taken it as 24 hours. And we talked about moon, retardation of moon, and we know that we learned about it last time that your lunar day is approximately 24 hours 50 minutes. The retardation of moon part of it, which I discussed in my last topic with you all. Now let's talk about a point called Aries, which is a point which is at infinite distance on the celestial sphere. Of course, this point is the one when when the sun is going from south to north, and wherever it cuts the equinox, which I'll be coming up in one of the topics later. But this is a point which is at an infinite distance, first point of Aries. Now, as I said, the Earth is rotating as well as revolving around the Sun. So it is moving, going along like this, and it goes round the Sun in 365 days, approximately about 59 minutes it covers up in a day. At this point, first point of Aries being very, very far off at a infinite distance. So this small angle of 59 minutes would not really make any difference to the direction of first point of Aries. And this is constant time. It's the true time for the Earth's rotation. And this is what we call as a sidereal day. Now here we are measuring the time with solar sun, mean sun. We have moved about 59 minutes ahead. So to complete a day, the Earth would have to rotate this extra 59 minutes before the mean sun comes in line with the meridian of an observer on this meridian. So Earth would have to rotate this extra 59 minutes, and that is about 4 minutes more. When we talk about the Earth, the mean solar day being 24 hours, and this being 4 minutes less, so your sidereal day is basically 23 hours 56 minutes of mean solar day. Now, this is going to be a progressive thing. Every time the first point of Aries is going to come 4 minutes earlier, then it comes, then the sun comes on my meridian, because the next day again it would have gone another 59 minutes. Aries would be on my meridian, but Earth would have to go to come onto the meridian of the mean sun would have to go another 4 minutes. So basically, that means that the first point of Aries will be coming onto my meridian, or as the word we use, culminating, that is coming on my meridian. If it is going to culminate 4 minutes earlier, that means it's going to rise 4 minutes earlier, it's going to set 4 minutes earlier. And that is what we consider. Even stars are far, far away. So stars also rise and set 4 minutes early. Now, this is just an example. What I'm just trying to show you here, January 17th, and these figures what are given here are for the middle of the day in the Almanac, which we had, I think, discussed when we were talking about the semi-diameter of Sun, the B and D corrections. They're all given for the middle of the day, but they are accepted for the all days there. So when we are talking about uh, Aries, now here we have been given meridian passage of Aries. This is your LMT meridian passage, and this is what we talked about, is that these certain things can be taken. Of course, everything is in Greenwich Mean Time, but like sunrise, sunset time, twilight time, all that can be taken as local mean time also, which I had explained in my previous one of the lectures there. Now here is another day here, which is 28th of February, which is about nearly 2 months away. Now, how did I get these days? What is 17 day and 59 day? We have a table in our almanac of days of the week and days of the year, which is right in the beginning of your almanacs, and from there you can get the day of the month, a day of the month here, and what is the week and what is the thing is given here. So here from 17 January, I got that is the 17th day, it's a Friday, and then February 28th I got it here. 28th, it's 59th day, and so the number of days between them is 42. Now it is coming 4 minutes earlier. So basically, if this is the time for 17th of February, It'll come 14 minutes earlier, 4 minutes earlier per day for these days here. So 17th of Jan is 16:14. I'm not talking about point 0.6 here, and it's earlier by 2 hours 44 minutes. So it is going to be earlier. So I just found out the time here, and that you can see that it matches nearly with the time given here. So Aries comes on your meridian 4 minutes earlier every day, and as I said, that is the reason that the stars also appear to be rising and setting up 4 minutes earlier each day. Now, if you had to find out the time for meridian passage for a day earlier, because as I said, it is given for this middle day, it has come 4 minutes earlier here. So whatever the time here is going to be 4 minutes more than this, and it comes 4 minutes earlier here, it has to be 4 minutes less than whatever the day is here. So if you have to find out what is the meridian passage time, LMT meridian passage time, you'll add 4 to a day earlier and subtract 4 minutes for the day after. Now this time of meridian passage, as we talked earlier, also was the reason to find out the declination. But if you look at it here, I have given you 2 days here, and you can see that the declinations do not change much. So basically, we are not really concerned with what is the GMT of transit of a star. But for us, for examination point of view, we got to know how to find out the GMT. As it's clearly visible here that GMT basically does not make any difference because they are not changing much at all. You can see it here. So for examination point of view, we got to find out. So let us try to see how we figure out to find out our time for meridian passage of stars. Now here you see that meridian passage time is given here. That's for the central day, middle day. Now I'm just assuming that I am on the western longitude here. So this is my LMT meridian passage, Aries. Let's talk about the star APPROX here. I've taken it up this because its SHA is 173. Easy to understand here. I've just drawn this dotted line, which is 180 degrees opposite to whatever my longitude is here. SHA, Aries to the body measured westerly, that's clockwise. So this is my SHA, what is given to me here, right? So when the Aries is on my meridian, and that day the SHA of the star is this much. This LMT, meridian passage, Aries, I know, star is there. 360 minus SHA is RA of the star. Now, we said that the Aries comes onto my meridian 4 minutes earlier each day. But if we just neglect that part of it, 4 minutes, and do not figure out the difference between the sidereal time, which is 4 minutes again, the star would come on my meridian after the Earth has moved this distance of RA, angular distance of RA. So if I convert this RA into time and meridian passage of Aries, I can come to the approximate time of meridian passage of star. So approximate meridian passage star, LMT meridian passage, and plus RA of star converted in time. That's without taking into account any difference between sidereal time and the mean time of 4 minutes. Now this is another thing which I'm just trying to show you here. You're on the easterly side, same star, SHA for 170, RA. So when will the star be on my meridian? The Earth has still got to move the angular distance of RA. So LMT meridian passage of Aries plus the amount of time taken by Aries. So the approximate uh, equation for finding out your meridian passage star is LMT meridian passage star passage Aries plus RA star in time. And this is basically what I'm talking about is only for your academic interest. Normally, nobody finds out the meridian passage like this. None of the books have mentioned all this there. So if you had to go in for a little bit more accurate thing, then you would have to go in for correction for longitude of the observer. And now the RA, what we have taken, we took it as we did not try to figure out that 4 minutes difference. So these two correction also would have to be applied. Now we talked about longitude correction already. That was when we talked about moon. So this is the LMT what is given to us right here. LMT meridian passage, and that is for the middle day. Now here it comes 4 minutes earlier. The same LMT is applicable here also, but it comes 4 minutes earlier. So the LMT here would be 4 minutes earlier than the LMT what is given to me. Without taking into account this 4 minutes, whatever I have said, it will be earlier. And because here it has come earlier than this, so that means the LMT here should be later than this LMT what is given here. So the longitude correction would be 4 minutes into longitude 360. And if you look at it, the longitude correction will never be more than 2 minutes, so it is basically negligible because your maximum longitude is 184 into 181. You can have maximum 2 minutes. It's negligible. That's why I said this is just for your academic interest. Now, if it is you are on the longitude east, you'll be adding it up because your time is going to be later, and for the west, you'll have to subtract it because the time is earlier. And then, of course, as I said, we did not last time. We did not bother about the difference between the sidereal day and the mean solar day. But as I said, for more accuracy, RA and coming early, it will always be subtracted. So 4 multiplied by RA into 24, that will be the correction for RA, and that has to be always subtracted because it's coming earlier, minus. So the more appropriate uh, equation would become meridian passage of Aries plus minus the longitude correction plus east minus west and correction for RA minus. As I said, I've not seen much of this being used. It's just only for your academic interest. Now, just a few examples here how to go about finding out your time for meridian passage. Now, this is what has been given to me 20th January 1992, and the star is there. So, what I do is I try to find out the star here, that is SHA minus 360 RA. In time, to convert this in time, and the formula is LMT meridian passage plus this. You can see the meridian passage for 20th is 1606.2. So I write down the LMT meridian passage 1602 plus my RA in time, and approximate meridian passage would be this. Then I apply the longitude and get my GMT meridian passage. As I said, this basically GMT meridian passage for star is just an academic interest because the declination what we require does not change much as long as we know the dates are correct. Now, if the question was given to you to find out the exact time, this is, as I said, is the approximate time, exact time, and we had done it earlier that when the body is on the meridian, the LHA of the body is 360 degrees. So I put the LHA star, use the SHA, use the longitude, get my GHA Aries, as you can see the formula here, minus, because SHA goes here, plus minus, and I get my GHA Aries. Now we assume that the date what has been given to me in the question is also the same date of GMT. right? So I get my time as here 163. Find out the GH Aries which is less than this, about 3 hours, and I write down my GH Aries. And the difference in my increment, what has to be applied. And stars, there is no V correction, so we don't have to bother about V correction part of it. This is the increment. And when I go into the increment table, I find that this time is 45 minutes and 22 seconds. Now this is my GMT. So I should see if this GMT is correct for my LMT. So for GMT, this formula here, I apply my longitude in time, and when I do it, I'm getting my LMT as 19th. But the LMT has to be 20th. So what I do is I add sidereal day which we just discussed, so that my LMT comes to 20th. And now my LMT has come 20th. So this is the thing, when you get your GMT, you always check up if the GMT is applicable to you for the LMT date, what is given here. And if you find that it is less or more, it is 1 day ahead or 1 day behind, you add or subtract your sidereal day accordingly. Here it has gone 1 day behind, so I have added one sidereal day, and now my LMT is correct. And then I can always find out my GMT here. So this is the GMT meridian passage for star Difla on this, on 20th January, ships, date and time. Now this, as I said, we can even find it out by looking at the almanac. We started off with LHA is 360 on that day. I use my SHA, and I use my longitude, and I get my GHA Aries. I've got my GHA Aries here, same as 175 here. Now, of course, for you all, you have to show all the uh, steps before you can go to deciding about the day, but that you can confirm later on. But right here, once you have got your GHA Aries, and when you look at your uh, tables here, you can figure out if the date has changed or not. So this, when I look at this for 20, the date was given to me as 20th. I look around where the GHA Aries is 0, because the body would be on Greenwich Meridian earlier than west and later than east. It would have crossed east and then come to Greenwich, and then it will cross the Greenwich and then go to the west Meridian. So it is here between 16 and 1700 hours GMT on the 20th. My longitude is given west. So it has to be after this particular time, not before, because the body would have already crossed east, but it has still got to go to west at 60, between 16 and 1700 hours. It's on Greenwich Meridian. So what I do is I look for this below, and here I come up here and I get my GHA Aries for 21st day, 164.44 from here, and increment, and then I get my increment, and that's my GMT. So you can follow any of these two methods to find out your time for meridian passage star. Another example here. Now I have taken Rigel, SHA, time. No, I have not gone further up from here. I've just done it. Of course, you will be doing the full thing here. because I know that the dates are changing, so I just made a shortcut here. I use the LMT 22nd, what has been given to me here. The Meridian passage time 2351.7 plus RA, and I see that my LMT date has changed to 23rd. So my time, what I have used here, should not be for 22nd, because if I take it for 22nd, it is going to 23rd. So I should take the LMT for a date previous, and as I said, previous day would be plus, because here it comes 4 minutes earlier than what it came here. So I take the LMT time here plus 4 minutes and work out, and now this is my approximate LMT, and then I can go ahead and find out what is my approximate GMT. Or I could just do it the earlier way, what I talked to you about, taking it as 360, using my SHA, my longitude, getting my GHA Aries, and as I said, I can just look at it here. Is it the right day or not? We are talking about 22nd, 348. It is somewhere here, 2300 hours. But I look when it is at zero, when the body, when the Aries was 0, that is when it is on Greenwich, right? If I went around with this, I would use the date 22nd, 2300 hours. But then when I see here, around 22nd, it will be on Greenwich between 23 and 0000 hours. And my longitude is east, so it should be earlier. So I would look for time earlier than when it is on Greenwich. And then I would go in for 21st and 2300 hours, 246. And same way around, and I get my exact time of Meridian passage star here, which is nearly close to each other. Of course, this is just a coincidence that they are coming so close. You'll find that the time would be quite different, at least in minutes, not in hours. In minutes, you'll have quite a lot of difference in finding out your time. So don't bother about it if you're getting difference in time. Thank you very much. I will continue with some solved problems next.